Let's take another example on reduction formula of integrals of the form x raised to power n cos x dx. Now we recall in our last lesson that in is equal to integral of xn cos x dx, which is equals to x raised to power n sin x plus nx n minus 1 cos x minus n into n minus 1 in minus 2. Now we are given this question to evaluate integral from lower limit 1 to upper limit 2 of 4t raised to power 3 cos t dt. Now since 4 is a constant, it can be brought behind the integral sign. So this will give us t raised to power 3 cos t dt. Now since this is similar to x raised to power n cos x, but this time the variable is just t. So the first thing we are going to evaluate is the reduction formula for t raised to power 3 cos t with respect to t. Now in this case, our n is equals to what? 3. So therefore we can say that I3 is equals to integral of t raised to power 3 cos t dt, which is equal to, so we are going to repeat the same thing we have here, but this time we are going to change the variable from x to t. Therefore we will have is equals to t raised to power 3 sin t plus 3 t raised to power n 3 minus 1 cos t minus 3 into 3 minus 1 of I3 minus 1. Therefore we know that our I3 therefore will be what? Our I3 will give us t raised to power 3 sin t plus 3t squared cos t minus 3 into 2 of I1. Therefore I3 will be t raised to power 3 sin t plus 3t squared cos t minus 6 I1. Now we are able to evaluate an expression for I3, and in I3 we have to look for I1. So let's evaluate I1 now. I1 now will be when n is equals to 1. So making our substitution, we'll have t raised to power 1 sin t plus 1 into t raised to power 1 minus 1 cos t minus 1 into 1 minus 1 I into 1 minus 2. Therefore I1 will be t sin t plus t raised to power 0 cos t minus 1 into 0 I raised to power what? I subscript minus 1. So this will tend to 0, and we will have I1 to give us t sin t plus, since t raised to power 0 is 1, then we have I1 is equals to t sin t plus cos t. Now we have an expression for I1. We can now substitute into I3, and our I3, which is the same thing as integral of x t raised to power 3 cos t with respect to t, will be t raised to power 3 sin t plus 3t squared cos t minus 6 I1. Now let's make our substitution of I1. So this gives us t raised to power 3 sin t plus 3t squared cos t minus 6 into t sin t plus cos t. Now with that done, we will have that integral of t raised power 3 cos t dt is equal to t raised power 3 sin t plus 3t squared cos t minus 6t sin t minus 6 cos t. Now, having evaluated this using reduction formula, then the question which says integral of 1 to 2 of 4t raised power 3 cos t is equal to 4 into 1 of 2 t cube cos t dt. Now we make our substitution that we have already integrated this, so this will become 4 into integrating t raised power 3 cos t. We will have this t raised power 3 sin t plus 3t squared cos t minus 6t sin t minus 6 cos t from lower limit 1 to upper limit 2. Therefore, we can now plug in our upper limit. So this will give us 4 into 2 cube sin 2 plus 3 2 squared cos t minus 6 2 sin t sin 2 rather minus 6 cos 2. Now this will be subtracted from the lower limit of 1. 1 cube sin 1 plus 3 into 1 squared cos t, that is cos 1, minus 6 into 1 sin 1 minus 6 cos 1. So when we use our calculator to simplify this, we will have our final answer to give us minus 1.223, approximately to 4 significant figures. So in our next video, we will be dealing with integral of x raised power n sin x dx.